Alright, sorry, I am running a touch behind this time. I did that thing where like, I got 5 minutes, I can get this done, and it took like a little bit longer than 5 minutes to do, so. But we're here now. Alright, so lesson 2 is about the ways of producing electricity. There's a bunch of different ways. All you really need to do is create a difference in the number of electrons in one side of a conductor versus the other, and current will flow to even out that pressure. Uh, a difference of electrons creates something like a pressure, and just like all pressures, water pressure, air pressure, the pressure will try to even itself out. So, a battery. So, just to get started, that's the core concept here, and we'll get into the lesson. A battery is made up of one or more cells. So you can just take a potato battery, and you're good. You have a potato battery, and you have that's one cell, and you can link potatoes together and create a multi-cell battery and actually increase your voltage that way. Um, the issue whenever I've done it in the past was the resistance in that potato battery, the internal resistance of the battery. You can only build the voltage up so high. I couldn't get enough voltage to power a light bulb. I had a little tiny light bulb. I couldn't light it up. Probably could have done it with an LED if I had one. Like just a single LED, not like a LED light bulb. Alright, piezoelectric is electricity created by pressure. That pressure, we use them in microphone. Like we use piezoelectric for microphones, guitar pickups. Uh, it doesn't create that pressure doesn't create a lot of voltage. It's usually used for sensing stuff or used for gauges, sensors, things like that. It's not a you're not going to power anything with the electricity that the pressure creates. Which one of the following is another name for the solution? Batteries have two conductive plates with an electrolyte between them. The two conductive plates are different metals. That's what creates the different amount of, that's what creates the imbalance in electrons. The electrolyte strips the electrons off of one of the metal plates and deposits it to the other metal plate. That's what uh, that's what creates the difference in electron. Or that's what creates the current flow in a battery. Which of the following is not a method that can be employed to force electrons from their valence ring? You can't do it with cold air. You need heat. Hot air would do it with a thermocouple. So electronic thermometers have a thermocouple in them, and that creates a small amount of voltage in the thermocouple, and the thermometer reads that voltage and converts that into a temperature. Uh, so yeah, friction. The whoever put friction, static electricity is created by friction. Uh, so there's going to be today. Read all the questions carefully. There's going to be a lot of tricky questions where chemical electricity is not created by rubbing one type of material against a different type of material. That static electricity is created. It's it is just one of those tricky questions. Chemical electricity is batteries. That's pretty straightforward. Uh, Probably whenever you saw the answer there, you were like, ah, that son of a bitch. What determines individual cell voltage for a battery? The metals used for each plate. So, yeah, I already covered that several questions ago. So we're going to move on. Heat. So, anytime current flows across a resistance, there is a power loss. Where does that power go? It turns into heat and is dissipated into the air. That's what that power loss does. It's always a power loss unless you want to create heat. Because then the heat is the goal. Uh, then there's other things that are created to. There's all sorts of inefficiencies that you can run down. There's the heat dissipation. Sometimes it lights up, and that's if the light isn't the goal. That's like those old style heaters or like your stove, an electric stove. It glows red. Well, that glowing is an inefficiency. If it heated up without turning a color, that would be more efficient than it heating up and turning a color because it's dissipating some of its energy as light. And that's not the goal of the object, so it's inefficient. Basically, anything an object does that is not part of its function is an inefficiency. I know you can't hear it, but the fans in my computer are making noise. That's an inefficiency. That noise means that something's not running at peak efficiency. All right. Thermoelectricity is heat generated by electricity. This is another one of those backwards questions, and none of the classes have gotten this one right. It's kind of funny. It's thermoelectricity is electricity generated by heat. And then finally, the chemical process in electroplating is called electrolysis. Uh, so it's on page 49 to 50. Page 49 to 50 is the full story. On page 50, the last paragraph of the battery categories is where it actually says things like electrolysis, and it talks about it just very briefly. It's like I said in the description, it's probably easier to Google that information up. It's yeah. Electrolysis is pretty cool. I looked into it a lot years ago. People will use electrolysis, basically get a vat of acid of some sort, and you hook up like a car battery or some sort of DC voltage source, and you put whatever you want to electroplate in there connected at one side of the battery, and it's called the anode and the cathode. I can't remember off the top of my head which one's which. But you put that in there, and then you put some sort of sacrificial metal in there, or a dye. You can put some dye in the acid, and it will, the current flowing through that acid will make the dye stick to the metal. It's it's really cool. I have seen, you can look up on YouTube some uh, cast iron restoration videos where they will take that acid and take just a piece of metal, just a piece of iron or steel, put that in there, and put the a rusty cast iron in that acid, and run a current through it, and it will suck the rust off of the cast iron, and it will go stick to the other piece of metal. And that's just really cool to me. I don't know, like, if that's cool to everybody else, but yeah. All right, that is all I wanted to cover in this lesson. The next one will be lessons 3 and 4, which may or may not go together that well. I'm not going to shuffle this one for you guys because I don't think those lessons are going to go together very well. And let's see, lesson 4, and let's find lesson 3. Lesson 3. Oh, I gotta move it. Move here. So let's go back. Lesson 3 and lesson 4. Oh, they're both out of the chapter 3, so it's not that bad. It's not as bad as I thought it was gonna be. So let's put chapter 3 first, or lesson 3 first. Merge. All right, let's give y'all the quiz now. Finish. Finish. Let's not shuffle the questions. All right. So the quiz is up. The next live stream will be at 2:45. So that's about 3 hours from now. You'll have a lunch period. I gave you 3 hours because of lunch. So you're not having to, like, work two things together. All right. Y'all have a good lunch. I will talk to you at 2:45.